Hello, welcome to Rubber Duck Engineering. Welcome back after a week of vacation. Tonight, we're going to do yet another programming language, which is yet another hobby side project that Adam and I made while we were doing Lisp and haven't touched in 3 weeks. But we're going to look through it tonight. Hi, Dr. Barth.
Hey, Eric. I'm just amazed that there isn't already a programming language called yet another programming language. It's such an obvious name for a programming language.
The internet is a very big place, Adam. There may very well be.
There may be, popular. Yes.
But yes. Yeah. Any news? Any things to share before we jump right back into the code machine?
I just want to talk a little about the motivation of this thing. So we were playing with Lisp in some of the previous episodes. And I mean, at least to me, Lisp feels pretty dated. Like it feels like it comes from a world where a linked list was like a super important data structure. And I just think that's not really how the world turned out. Like the world turned out that like JSON is a super important data structure. And so we were talking that we were thinking like, what if we did Lisp, but where JSON was the structure that you use for everything. So like in Lisp, you write your program as a bunch of linked lists. What if you had a programming language where you write your program just as JSON, and then it would be really good at processing JSON. And the same way you could, like, in Lisp, you can use the quote operator to get yourself a big chunk of linked lists. You could use the similar thing to get yourself a big chunk of JSON. And that very quickly did not work. So actually writing a program in actual JSON did not work.
But I think we should talk a little bit more. But I really like that dream because so I was learning Lisp as part of this Lisp interpreter. I'd maybe seen it a little bit, but I was really learning it as part of doing, similar to how I learned JavaScript by working on a JavaScript interpreter. But Lisp has this beauty, despite this dated feeling of the being written in the same data structures that it is operating on.
I think you found some name for this, right? Some like crazy, what was it like? IDEO sin something.
Yeah, I remember.
I can't remember. It was some like fancy sounding word that meant exactly that. That the programming language was written in the data structure that it could manipulate easily.
But I've not used other languages for which that's the property, and I don't feel like I've written enough Lisp to really exploit that property. But it seems interesting. But yeah, as you alluded to, we initially started. So we were doing this on the side while we were doing the Lisp thing. The Lisp thing was our
day hobby, and this is our night hobby. How many levels of
Thursday hobby? This was our Saturday hobby.
What levels of stacked hobbies do we need?
Anyway, so while we were doing our Thursday hobby on the side, we had our Saturday hobby, and we were working on a JSON version. And so I'm actually, the wires have gotten crossed several times in my brain as to where the status of the various projects are. But as you said, we started out trying to write in JSON. That proved impossible. We moved to YAML because YAML is a subset, a superset of JSON, and that's been slightly more tractable.
I think it's totally feasible. Like I wouldn't say this project has been like a roaring success, but I think it's like it was working. Like we wrote. We'll show you. Like we go to the code machine. Maybe we should go to the code machine and start giving the tour. But in the YAML approach, we were able to write some non-trivial programs.
Yeah, we did. We wrote some. I mean,
they're small programs. They're not like. It's not like we're writing Serenity OS here or anything. Like they're small programs.
But like, here's Hello World. So we exploit this is a map in YAML, and we say a map that has a single key. We assume this is the function name, and print line is a built-in, and then this is the string that's passed to it.
And it works. Do you want to run it just to like?
Sure, to prove people that we built a thing that can do that.
Yeah. But it kind of makes sense, right? Like the value for the key is the argument to the function. And then
I think this is a little inelegant, honestly, because I don't think print line should be a built-in, but it is for now. And it like got us going. And then I know we added lambdas at some point.
So here you see one thing you see here, so like let is a macro basically, or built in. And then it has a second, its map has a second key in it, which is this plus in key. And so the plus means this is not the function that you're calling. This is like other data that's being passed to this function.
Correct.
And so let its argument is a map that then it evaluates what's on the inside and creates a scope like we saw in the previous episodes, and then evaluates the value of the in key in the scope that has the binding set up.
To restate, like if others know of languages that have done this, I would love to see it. We did not find one. We did not find a language that had lists and or arrays and maps as primitives.
And so then here the lambdas works the same way, right? So lambda is a special form. So it's the lambda key in the map says this is going to be a lambda. And then the in key says here's some additional data that's going to get passed to this lambda. And then the key, the value for the lambda is then a description of the arguments of what you pass. And then the body is then evaluated with those bindings. And then the $sign function is a thing that does a lookup in the environment.
Yep. And we have non-modifiable environments currently. We may change that. So that's why we need this let in behavior. You can't just define a function. You have to scope all of your declarations. So when we let greeting be equal to this lambda, that greeting is then only valid within this in context.
So here you see one of the interesting subtleties of using YAML as the syntax for the language. So let's see if I can highlight things in here. So here, this world is also a string, just because that's the way YAML operates. If you don't quote a value, it just becomes a string.
Yep.
And so normally in a programming language, you use the unquoted sequences to mean evaluate this thing in the context. Yep. But that didn't exist in the syntax. And so we had to create this built-in function. And it's just literally just a built-in function that does the lookup.
Yep. In Lisp, instead, they have symbols. Right? It's like, you're saying, sorry?
Yeah. So in Lisp, they like well, you don't even have to type that. Just typing, like if we were just to type subject without any decorations in it, in Lisp, that would mean look it up in the environment. Yeah. And then they require you to put the quote marks in to turn something into a string. But in YAML, it's not the case. Everything is just a string by default.
And we toyed around, and you can see in this Adventure MD with, what would it be like to like design some sort of like custom language for it. But this was very early on, and we didn't come back to this. We tried to hold ourselves to an existing parser, be that JSON or YAML, to get this far.
I think if we take a look at named arguments, I think it's also an interesting case. This is sort of the first interesting thing that this language does that Lisp doesn't really do. So here, Lambda, instead of presenting a list of arguments, it presents a map of arguments. And so the maps are then named arguments. And then when you call the function, you provide a map. And then that's essentially like a named argument, named parameters to the function.
Yep. Let's see. We also implemented a built-in for quote. So you could return JSON. I guess we implemented both serialization and deserialization.
Yeah, we figured if the language is based on JSON, it should be really good at serializing and deserializing JSON. So we made functions for that.
Maybe we should show some of the code.
Sure. We can show the test harness. So these are all sort of, I would classify them as kind of trivial programs. So this is, we decided we should build our test harness in the language. So this is a non-trivial program that imports this golden test library or package.
Yep.
And then declares a bunch of tests. So the thing that we're sort of going for here is we really wanted this language to be like a DSL language, where the thing that you're building is mostly DSLs, and then you're using YAML as a syntax for your DSL. And so this was an attempt to try to do that.
Which is what Lisp does too. Lisp is really a way of writing DSLs.
So like you remember in the Lisp project, we had our golden test file, which was a separate file format that had this sort of input, output, and then we parsed it, in Rust. Here, the idea is we want to give structured input to our program that contains the test cases, and then just have them run.
And you can see this is the library, the golden test library, that actually makes those tests work. So we export this test macro. We're defining a cases helper here. And then we're defining a test helper here. And then we're setting actual equal to the eval of the in. Yep. And then if they're equal, then we print pass. Otherwise, we do fail, serializing the in. Yeah, serializing the in and out. And then we do this all, we map the provided, use the test function over the provided cases. Did I get that right?
Yep.
Yeah, because test is itself just a macro that takes the cases.
It's just a function, yeah.
Yeah, so we're just calling tests here.
It should be a macro. Like we wish we didn't have to quote all this stuff, because if it was a macro, then we could. That's what this fix
I
was
see,
about.
but we haven't done macros yet in this language.
Correct. We did macros in Lisp as the last thing that we did, but we didn't do them in this one.
Well, there again, the wires get crossed for me, remembering what we did in one language versus what we did in the other.
And this actually works, so I think we should demonstrate this working.
Yep. There we go. Test basic. Pass, 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 pass. So by running this file, and we can verify that in foo.
Yeah, it's a bit like XSLT. So XSLT has the same sort of flavor, where you're writing an XML description of this transformation that you want to apply to XML documents.
Yeah.
So right now, so now we talk about sort of like what we're thinking next. So this is very like command line oriented, like it's printing out a bunch of stuff. But what we're thinking is this should be really good to write like a JSON RPC server in, like a thing that takes in a bunch of JSON, thinks about it, maybe calls out to other web services, and then returns you back a JSON blob. Because a JSON RPC server, its life is dealing with JSON. And so it seems like it's a good candidate for a kind of application that would want to be really good at dealing with JSON.
Yep. We wrote ourselves this to-do list right before the show. We realized that we put the plus on the wrong thing. If you look back at we're putting the plus on.
Yeah. I'll say, like, it's a design question. Like, okay, why do we think we put the plus on the wrong thing? Like, how did we feel that? Or like, what was the design pressure that led us to that conclusion?
How did we get there? Well, I mean, we were discussing how export is unnecessary. So right now, we don't mark the special operator. We mark all the non-special operators, which is it sort of is nice for the single case where it makes that your what is it, the hello world, not have to have a plus here, which is nice, but it at the cost of making all of the others more complicated.
For a very simple language adjacent to this recently, it's basically math in JSON. So you can do stuff like, and then a blank. That sounds cool. Yeah, so like I think a way to think about this, if you go look at the code, like, or when you're writing in this language, you often get confused about like, am I writing a map that's going to be evaluated as data, or a map that's going to be operational and be executed? And because the default way, because the like operative or the function call isn't marked in any way, it's the different contexts are different, and it's confusing. And so we can unify those contexts by saying, oh, it's mostly data-like, except if you mark the execute thing that you want to execute. And then you can get rid of this export at the top of this file, because all this export is doing is basically taking its argument, taking the key and evaluating it as data instead of trying to execute it.
It's really just like quote.
Here's an example. Constants: width, height, size, area. Yeah. It's a very similar idea. But we were trying to go even further. Like for us, the star, we wanted the star to be like, you see, you have width times height here. The syntax tree inside that expression is hidden from the JSON structure. So we wanted to go like full on Lisp, where all of the like the AST for the language is fully structured in the data structure.
I mean, I have to say this is it's pretty awkward to write in this.
It is awkward. Another important thing to think about here is we talk in other episodes about failing at things, and I sort of feel this as a failure, but I think it's an interesting failure. Like I learned a bunch from doing this, and I kind of like I'm not quite ready to declare defeat yet. Like I still want to like poke it with a stick, and try some stuff.
I don't think we've taken it far enough to actually. I mean, part of failing is like you got to go far enough to learn.
Yeah, so Ashley was saying that they were solving a very specific problem with their language. Yeah, so that's also a good way to do things. We're not solving a specific problem, like we're sort of exploring a space. So like a kind of like what if the world was like this? What would it be like?
Yeah. I mean, going back to this feels really awkward in this language because this language.
Yeah.
Go ahead.
No, go for it.
Just because this language is, I think, should be based on JSON. This is how we got to the like this should be doing JSON servlets, or little JSON.
Right. This is like not playing to its strength, right? It's trying to create a string, and instead of it was creating like what if the thing was trying to return reply, right? Like reply with result pass. Right, and this was like reply, like result, fail. What was it? Case in actual expected.
Yep.
We did take away like the stringy aspect of it. Like if it was a JSON RPC server and this is the JSON blob I was supposed to get back out, like this somehow feels nicer because I'm making use of the fact that my language is JSON, and so it's very easy for me to construct JSON.
Well, it actually would be really easy for us to even just have done this. Like even just to put the like I don't know that we could write the reply function, right, and wrap this whole thing in that function.
But I think the structure where we're doing this is not right. Like we're doing it as a command line program that like prints a bunch of output. And I really think the next step for this is to turn it into a web server where you're pinging it and it's then sending you back JSON, because it feels like, I don't know, it just sort of feels like more like what it wants to be doing.
So is that something you think we could do on the show here, or we've done part of a tour? We could do some more tour of the code.
Yeah, why not? Like we could try.
Okay.
So I sort of feel like we just to give a slight tour of the code here. Like there's, as you see, there's this bin directory. So there's 3 different like embedding programs that embed this library called VM, and the VM library contains all of the actual executable code. So I think it's just creating a new embedding program. Yeah, there's like extremely little code in the actual VM, which is kind of what's cool about it.
Yeah, this is the whole thing. The mod file, I don't know why it's called mod, but it is the whole programming language.
Oh, mod is just in Rust what you call it, the like root file of the directory.
Oh.
Yeah.
Oh, I didn't know that.
And then built-in has the built-in functions, which the library will grow. But like,
I see. Yeah, I mean the built-in is pretty. It's print line. Just like these should be removed. These should be kept. This is a helper for getting the parameters.
There's your implementation of Lambda. There's the whole thing. I mean, it's very similar to Lisp.
Yep.
Like there's the lookup function, the $.
Yep. This is the $. It could be non-recursive let. Oh, this is, yeah. So this is where we chose to have an immutable environment. So we always create a new environment. What did you say?
I think import is an interesting function to look at too. Like, so import was not like, it looked like a keyword, but this is all it does. It just goes in, reads in the file, like evaluates it and shoves it in an environment.
I'm just reading it again here. Path name, path join, program, parse program, exports value. I see. We eval it. If we got a string, I see. What? Exports. Hold on. Eval. Why should eval return a string?
So we did something, this maybe we're being too fancy here, is the import operator, if you gave it a string, it would put all the stuff from that library in that value. Otherwise, it would import all like into your root namespace. Anyway,
okay.
And then,
oh, I see. Okay. So this is the actual eval down here. Oh no, sorry. This is the eval of the in. This is the verb. I'm still lost. Sorry. The eval root environment.
So that gets the
parse
exports.
Program. This should return a map, shouldn't it?
It doesn't matter what it returns. It just returns some value, and then it's switching on the. Yeah, it's switching on the value of the import key. Like you say, import is like as, right? You say like import golden test as foo.
Oh yeah. Oh, sorry. I thought this was. I read this as match of exports. No, it's match of value, whatever value is. I see. And then it's just take whatever the exports is and shoves it in as the name. All right, that makes sense. An export, as you said, this was just basically our this was necessary to convert our thing that we thought was code into data.
Correct.
And then map, this was how we map like mapping over a list.
We just ends up calling the Rust version of map to map over the list.
And then this is if, this is equals, and this is plus. We didn't do the rest of math.
Plus ought to be enough math for anybody, right?
Okay.
So I think we could just create a simple, like a new embedding program that just spins a web server and does something with like somehow like maybe reads in a program, and then whenever it gets a request, it somehow calls into that program to get a response for that request.
Yeah, we could even fake it. We could make a program that reads in JSON, shoves it into this thing as a request, and then prints out whatever the JSON it replies with.
Okay, that sounds like a good idea. Like using standard in, standard out as our like mock server.
Yeah, just to save ourselves from having to go import on HTTP library or whatever.
Okay.
You modified our golden test.
Yeah, I think we should just revert that. Like we'll come back and make another example program for this.
Oh, I see. You ready? I'm holding the undo button key. Okay, there we go. Okay.
So we have REPL. We have interp. So I think this is sort of like interp. We need a new kind of interp, like serve.
Yeah, we can just.
Just copy interp over there. It's similar, right? So like it's we want to read in the thing. We want to parse. I don't think we want to evaluate quite yet. But we also want to read from standard in. Well, let's parse, right? So let's see, let program equals parse the input. Okay.
Yeah, how does this thing know what to call?
I mean, we're gonna have to make this up, right? This is part of the trick.
Like, so are you imagining building a REPL here, or Uh,
I was kind of imagining just the a one-shot one to start with.
mhm.
But we could do more than that.
Well, you definitely want to parse and eval it, but then you want to like hold on to some hook.
We need to figure out like what is the hook. So the hook could be like main, or it could be like handler or something like that.
So how would this work if this was actually serve? The serve would be written in YAPL itself.
Well, I think it's like we're struggling with like, do we want a control inversion, right? Do we want to run the main and have it listen for requests and spin its own loop, or do we want to have it basically be called into from the server and be like, okay, here's your request, go give me the response now.
Well, let me channel my Stephen Covey here and begin with the end in mind, right? To go back to Ashley's comment about they were solving a specific problem, right? I think you want to imagine a world in which you write these things and they're super small.
Mm-hmm. Right. So I don't think you want. So what we're getting is you don't want the ceremony of like starting the server and blah 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 blah.
And maybe that's because you use a library to make it super small.
Mm-hmm.
But yeah, I think you don't want the ceremony.
Okay, so then I think the simple thing is we can parse and eval what we get, right? Let's bring that back.
We basically can write the ceremony in Rust, right? So we parse it, we run it, we assume that it returns a.
We're going to somehow get like
a handler's map or something.
Data equals like read from standard in somehow, right? Let's just assume we're going to read in who are, okay? We'll write the code for actually reading it in a second. Okay, and then we need to like call some function this thing creates. So I'm going to say the whole thing just evaluates to a function that we're going to call.
That would be reasonable.
I'm just going to say call.
I think Ashley's comment is haunting me.
What is Ashley's comment?
Well, or just like they alluded to this idea of that, like you build a thing for a reason.
Yeah, I mean, like this is.
We have to imagine what the reason is here.
The reason I'm imagining is I want to make it really easy to deploy JSON RPC servers like in the cloud, right? Like I don't want to spin up a container. I don't want to spin up any of these things. I just want to be able to even send like a request to one to be like, okay, now I want you to become this. Here is your program in JSON, and I want you to be really good at like packing and unpacking JSON. It's not really a specific problem. It's like a made up problem, but it's like a made up problem to try to explore this space.
Yeah, I mean, if we pierce the made upness, like I think there are other technologies that are competing with that for a solution. You know, WASM being one, right? You compile your thing to WASM, and then now it's like a blob you can send around to interpreters. So I think the interesting bit here is the JSON-ness. The lispiness, like you would choose to write something new in this because it was really good at expressing DSLs in.
Ashley's trying to unhaunt you.
Oh yeah, there's a value in just exploring. Yes. Okay, we just keep going. I'm like throwing my mental grappling hook here, and I'm just trying to like latch on to like where we're going.
It's super mad. I don't know why it's super mad.
Why is it super mad? Let's see. It's super mad. Mismatched types. So as you're writing this, I'm thinking that this is very similar to the like the unit tests.
Yes, we make lots of useless things.
Yeah. It's very similar to the unit tests.
Yeah, but I just want to give a gold star to this comment. Like I totally agree with this. Like it's yeah, similar to the unit tests. How is it similar to the unit tests?
Well, so you could the whole of the unit tests, these right, you could imagine these as this is the thing that gets bottled up into JSON and sent across. This also
like I want this like in out to be the like input that I throw at the server, and then I want the output to come back as JSON.
well, you expect it to get bottled up. It's nice to be able to write in your DSL where this is just a string. But then the underlying mechanism that should.
Well, I think like you're getting at sort of like a microservice thing, right? You want to have a microservice whose job it is to run the tests. And then you want to have another microservice that its job is to take the list of tests, fire it off to the other service to like execute the tests. I guess there's an interesting like space here, which is we have this idea of a function call that's quite easy to pass JSON to and return JSON from. We can make it very transparent or very the caller would need to know whether the function call was executed locally or was shipped off to some other microservice. Because in the end, it's just taking JSON in and returning JSON
out. As a slight aside, I'm actually very interested in that specific space, separate from this, of the transparency of client and server. Because I think the client server things are just way too hard. And it should be much easier for you as an author to just not care where your code gets executed.
And part of that is because it's like serializing things is tricky. When you want to go from client to server, you have to bottle them up. But if everything you work with is already just natively JSON, then it's already that problem is already solved for you.
To just explore the space for just a couple minutes. Yeah. Can we think about like what are crazy things you could do with this that you couldn't do with other languages? Maybe we should quest towards one of those. Like the DSL thing, right? That's relatively crazy. Like outside of Lisp, you don't do a lot of this. I know I always hack at it. Like whenever I write Dart or whatever, like I write all the custom. Like I always end up writing DSLs. They just are never quite this concise.
I mean, I think I think you could do with this kind of thing is the same thing you do with a Clang plugin. So in a Clang plugin, you're writing a program that's operating on the syntax of another program. And because C and C++ have very complicated syntax, you have a very complicated system for interacting with that syntax. And so writing programs that operate on other programs in this thing should be fairly straightforward.
So maybe that's our JSON in, JSON out. Maybe that's our RPC system. Is maybe the thing that we should write is a program that takes in one of these and spits out another one.
Okay, I mean that's sort of the concept behind the tests macro here, right? It's taking in a bunch of JSON and it's emitting another JSON, which is as you want to separate the compute. For example, you want to say I have one service that's good at taking my DSL, generating all the code needed to execute my DSL, but then I'm going to send that somewhere else to actually execute it.
I'm absolutely certain that we could write serve.rs. And it may actually unlock some interesting things. But I was trying to like jump more directly at the interesting. And I think what you just said occurred to me. Like, what if there was a transform dot rs or whatever that took, or a transform dot YAPL that took basic.YAPL and like evaluated it out, or like partially evaluated it out.
So you're going sort of like what James R was saying at the beginning about the XSLT, where XSLT was taking XML as input, giving you XML as output. You want to write a transformer that takes the JSON as input and gives you JSON as output.
Well, isn't that what the JSON microservice that we were discussing does? Takes JSON as input.
Yeah, that's sort of yeah. Yes.
Anyways,
should we try that? Is that what you want to try?
yeah. How do I help us get to? All right. So what would that look like?
I mean we just rename this to that and try transform. So the same thing, right? We got our program. Here's our transform now. So we want to read in our data from standard in, which we still haven't done. And then we want to call our transform on our like input data.
Mm-hmm.
That's going to provide some like output data, right? And then we want to basically print the serialize of the output data.
Okay.
Sure, print that. Okay. Now we just have to fix all the squiggly like ones.
So like for this, then this should be print ln.
We should actually read it in from standard in. This is kind of.
Or just read it in from the past file, right? Like this could just be like interp does. Is the only difference between this and interp that it prints out as JSON?
The difference is interp throws away the value that gets evaluated because it's assuming that what you care about is a side effect. Like it's assuming that we care about is all the print statements inside of it. So we're removing that assumption. We're now saying, no, you actually care about what this evaluates to because you're going to use it to transform something.
Okay. Huh.
There must be a way of just like reading standard in into a string in Rust.
All right, let's try it. Oh, reading standard in? That's where I would just go to a file, but I don't know.
They want to do read line, but I bet there's like another thing like that. So here's what the example I got from the Rust docs.
Okay.
Buffer is a new string. But whatever this is, I'm sure this thing has more functions on it besides just read line. Can you use your power of autocomplete? Read to string. Nailed it.
I'm not sure we nailed it here. Okay, what do we got? Method read to string for standard in. How do you know when the value?
I think we're just going to depend on external framing. So if this were a web service, it would be like framed by HTTP. And so here we're just going to wait for standard in to terminate. Like you're going to have to type Control D or just be done with the input. Is the indentation significant in YAML? Yeah, it's totally white space sensitive and indentation significant. It's amazing, which is also kind of annoying, honestly, when you write your program because you often have to like
re-indent,
and then you're slightly wrong.
Yeah,
and it just like does totally the wrong thing.
Yeah, either I think to actually make something mutable, either you would need a mutable environment, or you would need some different language. Or some different syntax.
Yeah, we had toyed around with using like another syntax that had some like would compile down to JSON.
It felt very reminiscent of the Flutter discussion of just like trying to hold that off until you absolutely need it. We talked about it in the past. This is still not working.
I'm trying to figure out what functions this has.
Expected at stir, but found string. Fine, sure. I'll give you a reference.
Read to end apparently is the answer. Read to string. There's a function called read to string. Is what we want.
Okay. It did not like it before.
Okay.
Trait found, not satisfied.
What's the trait? What string?
Error. What do we got? Is this result supposed to
I was thinking this in the Rust docs. I don't know why.
I don't know what this read to string thing is.
Okay.
I don't know if I can...
Items can only find if the trait is in scope. What is the trait? Oh, I need to import the read trait. Okay, where does the read trait come from? I have a trait read, really? I need to import this trait in order to be able to...
Unresolved import IO traits.
Okay. Now I can read it to a string. Crazy.
Okay. Following types. Result TF from residual result infallible E. Yeet E.
Yeet. Okay. So it's is it mad?
Sorry, I'm still stuck on yeet. Go ahead.
Yeet is a keyword in Rust, apparently.
There was some thread on Twitter a few weeks back that was it was like some dialogue between a kid and their mother, and it was like they said the word cringe, and it was like, has cringe been yeeted?
Kids these days.
Yeah, it was kids these days. It was the whatever. I clearly ruined the joke, but it was funny, and that reminded me of that.
I think this is all about Rust error things.
Okay.
Thing
Standard error not satisfied. Following types. Does this need to be? Does this anyhow result need to have VM error?
That's okay. We're just gonna map.
I don't know.
There's a more elegant way of doing this, but we're just gonna map error everything into an anyhow error.
Okay. Oh, I see. Because this is an anyhow error. Why are we dealing with anyhow errors?
I don't know.
Like, okay. What did interp do? Interp must have handled this. Oh, I see.
We can also just unwrap. We're fighting like Rust's very, very precise error handling. It's going to be great. If we have any errors, everything will crash.
Rust is wonderful, but it is not friendly.
Okay, we're going to crash everywhere. It's going to be wonderful. Okay, so why are you mad, bro? Oh, this needs to be a value. We need to turn this into a value.
Oh, input data. We have to parse it.
We have to parse it. Yes.
But it's serd YAML, right? Oh, I see. Parse. Yep.
It doesn't parse it, the program will crash. Great.
Okay.
We got rid of all the squigglies?
We got rid of all the squigglies.
Okay, so we need to write our first... Let's write a transform example.
Okay.
Identity. That's a transform, right? Like lambda input it.
Mm-hmm. Returns input.
Input.
Okay. Because we don't have explicit.
Wait. No. $sign. It's also annoying. The $ signs are also annoying. The whole language is very annoying.
Okay. Examples, identity.
Oh, we don't want to interpret. You want to whatever we call it, transform it. Yep.
Okay. Open target.
Oh, transform with an S. Okay, now you have to type correct JSON, otherwise the program will crash. Now say Control D.
Why couldn't we just read from a file?
You can pipe it in from a file. That might be easier.
I don't know. This is Windows.
This is Windows.
I have no idea how to pipe in PowerShell.
Maybe echo. Can you echo pipe it in?
I really have no idea. I'm gonna look up
How to pipe from a file in Windows. It must be possible.
the pipe. There's a pipe character.
You can go from a file.
But I don't know. You and your Unix biases.
Just what I'm familiar with.
Cannot run a
cat. You want to cat it?
Yeah. I'm sure there's some like what?
Okay. Undefined symbol input.
Okay, I don't. Okay, pipe a file, standard in PowerShell.
No, this worked. This was great.
This is correct?
Yeah, our program is busted. We have an undefined symbol.
Oh.
Why is dollar input not?
Maybe just put in a
more quotes.
Yeah, I think more quotes. That looks better.
Hey, it worked.
Okay.
We piped the input program to itself, and it returned itself. Like this is. Don't we win like some kind of computer science award for this? This is.
Okay. All right.
Well, what else do you want to put through the identity function?
Well, what if we write something more useful, like something
What's a more useful transform that we could write? We could write the test transform, right? The test transform. We'll just extract the test function from golden test, right?
Mm-hmm.
Just this function here. I mean golden test YAPL.
I see. So you write the tests as a transform instead of.
So let's write like a new folder here, which is like transform way. Okay. So let's write the test transform. So what is a test transform? We don't need this. It's just a lambda.
Mm-hmm.
Okay. It takes in and out. Not the actual. Okay. We don't want to print pass. We just want to return something.
Mm-hmm.
But here we have to use export because we want to go into evaluative form, right? It's annoying, but that's fine. This is the thing that will be fixed when we get rid of we move the pluses onto the operators.
Oh, export is like our quote here, or?
Yeah, export is kind of like quote. It's still evaluating, but it's evaluating as an object as opposed to as an operation, which is, I think it makes sense to get rid of the distinction between object evaluation and operation evaluation.
Okay.
So this is fail. And then this is like input, just the input. Okay. Expected is $out, and actual is actual.
Mm-hmm.
Okay. Then maybe we should make a test. Like we grab one of our basic tests, like hello.
Sure. Okay, so this is going to be cat. Yes. Transform way. Hello. S transform test. Pass.
Result pass. So what if I make it fail? Just for the sake of seeing that. Try it again. Yeah. Actual, expected, input, result, fail.
That's kind of cool.
Yeah, I mean, I can sort of see how you could build up a string of these, like a lot of transforms. Like especially if we had a way of invoking other transforms from inside the transforms. This test .YAPL thing feels better than the test in Golden Test because of the thing we were talking about, where it's not like print feels like a really foreign operation in this world, but this thing of like, and especially if we can get rid of the export world, like,
which we know how to, like that's steps away.
We know how to do that, right?
It feels good. Get rid of the variable lookup somehow, because
So I had thought about that too, right? So what if you did the variable lookup like this?
Oh, yeah. I mean,
then it's like Perl or whatever. Like so, this becomes like a string interpolation, where you can actually write like foo bar, and it would like pull in. No, you could say not. You could just say strings that begin with $signs are, symbols.
Yeah.
So what would this look like in that world, right? So then do that everywhere to see.
To talk to our listeners here, like this sort of, we talk about this as a check writing, but this sort of like imagining is important.
We actually fully transformed this file to what we think it would be like if we had our if we realized all of our dreams.
Well, it's now going to need to be plus led.
Yeah.
Right, and plus no.
Yeah.
Plus eval. Mm-hmm. Plus equal.
Mm-hmm. If you ever found $sign, can you forward declare the symbols? You need to escape the strings. Yeah, so that's another way of doing it, is to say, by default, the strings are symbols, and there's some extra thing that you put, like a single quote or something, or a backtick, or like whatever is convenient syntactically to mean, no, now this is a string.
Does this basically any key with a plus? It's like the anti-quote is like quote assumed basically in this world.
Yes, it's like the it's like execute, right? It's like the
you can just like add in random data and that's totally fine. But plus means, hey, this key.
This is like the pointing, right? It's like the pointed key. Like this one is, I want you to run this.
Whereas this statement here, how does this get turned into a return?
The whole thing just evaluates to that. So just the if statement evaluates to its then clause, and this is just a map, and the map evaluates to itself. Okay. Because it has no other operation. The default operation, if you will, is just identity. Yeah. So there's a question of like, do you want to have special syntax? But the reason, I guess one reason not to do that is if you want people to be able to, if you don't want the language constructs to be special, if you want the programmer to be able to define using macros things that are the same as your language constructs, then you don't want to have special knowledge of strings like in. You want to at most have little markers that you could put.
Yeah, that's one of the great things about Lisp is that there's very little special. Yeah. I actually don't know if you can like can you override plus? Like how do you?
Yeah, plus is just a symbol. It's just the plus symbol.
I see. and it's just defined to have a lambda associated with it that like adds things.
Mhm.
Okay.
Anyway, I don't think this is a programming language I would want to use, but like I think it's interesting to think through and like say play these sort of like what if games.
It's funny, James bringing up XSLT. XSLT was something that I encountered really early on in my career. Like after I brought SVG to Safari, or as part of like as doing that when I was moved to the Safari team, one of the first things I was asked to do was to add XSLT processor to WebKit. It was like a compatibility thing needed for Internet Explorer. And I just remember really disliking XSLT, my very limited exposure to it.
And XSLT has several advantages compared to what we're doing here. So first of all, the like all of the markup language, like things like HTML or XML or whatever, they have a pointed thing, right? Because the tag name is the thing you're pointing to, and then the attributes are the rest of the map. Something that's interesting that you never actually want to use. Yes, exactly. Yeah, it's sort of like that. And then the other advantage that XSLT has over what we're doing is the namespacing machinery in XML allows you to carve off spots. So what makes things operational in XSLT is being in the XSLT namespace. And so like the separation of like the plus and the dollar or whatever is all resolved because just you say use the namespace structure to pull out the things that aren't data.
I mean, the dollar sign is just I mean, we could do that here too. You could say that the way that if this was, you can't. We could just put XSLT colon in front of things instead of plus, and it would be the same.
It would be the same. Yeah, you're sort of stealing a little bit from the like underlying whatever you're doing. Somehow you're stealing a little bit from the purity of the data that you're transforming, because whatever you're using to mark the special ones is something you need to. If you actually needed that data, you have to somehow escape. And the neat thing about namespaces in XML is you don't need to do that because the like XML namespace machinery takes care of that for you. Like you could,
the whole QName thing is built in the qualified name.
Correct. You don't have to use the string XSLT as the local name for XSLT. You can make up your own my XSLT and just bind it to that URL.
The difficulties that I remember that I maybe now just 20 years later looking back at it saw with XSLT was that it was super verbose, and XML having this fail hard was just it turned out. We know now 20 years later that that's the wrong default. Maybe that was needed for XSLT.
Yeah, there's similar problems here, right? Like this also sort of fails hard, and it's like it's also verbose. Like you saw, like if EQ, like that took up like 4 lines of code to do, right?
So what is it that? How does Lisp get past these? I mean, I guess Lisp isn't like a mainstream language either, but
well, Lisp is also the pointing is solved in Lisp because in lists the first element is the one that's being pointed to. And it just is verbose. Like that's like if you want to write just a normal math expression, like Ashley was doing, like multiplying and adding and stuff, you have to write tons more parentheses, and it's going to take tons more lines to do.
But I think it recovers from some of that with the DSL. The everything is a DSL in Lisp. It really pushes you down the DSL, and then you end up actually writing less code.
Right, because that's where you're getting the sort of leverage, and you're getting the like efficiency of the languages, because you end up not writing in Lisp, you end up writing in your own language.
Writing a language for yes, and this is part of the reason why we avoided creating yet another pretty printer when we did Flutter.
Yeah, there's a huge cost to just creating a syntax for a language, because you need the pretty printer and the formatter and the syntax highlighter and the
the plugins for all the things. And
that was actually the cool thing about, we just told like Visual Studio Code that, this YAPL extension, that's really YAML. And we got all of that just for free. Like
we actually could have gone stronger, because you can give it JSON schema. And so we could have educated it a little more about our YAML. So anyways, sort of a wild and crazy detour into a side project that we had going about 3 weeks ago.
Yeah, I think it's like I hope you enjoyed like a look at the sort of design and thought process of like what goes into these kind of things, and like many of these things don't pan out, and that's fine. Like, but they're still like you build like muscle and skills by studying them, and you also just learn things.
Any other thoughts before we close for the night?
I feel like you asked me this in a lot of episodes. I'm really bad at open-ended questions. I get this at work too, where people end the meeting and they'll just like throw this huge open-ended question at me, and I'll just be like deer in headlights. Like I don't know what is my biggest worry about the like life. I don't know. Like,
well, I will tell you what I'll share is I played golf twice in the last 10 days. It was amazing. I hadn't played in probably a year, and then probably before that a decade. Just it was nice to go take a walk. Well, they say it's like golf is a nice walk ruined by I don't know, ruined by too many strokes or something. I don't know, but it was.
do
Do
you keep score when you play golf, or is it like a?
No. The people I was playing with, they kept score, but I did not. Playing golf 3 times in a decade is not keep score worthy. So, anyways, wonderful to see you, and we'll see you all next week.
Yeah, see you next week. Thanks for coming.